Hey guys, welcome back to Unit 8, Day 5 notes, I believe. Um, we're going to start this section with perfect square trinomials. So a perfect square trinomial is the same factor multiplied by itself. So it looks like x plus 2 squared, which we can split up into two terms, x plus 2 times x plus 2, and then multiply it out to get this trinomial. There are two different perfect square trinomials. There's a positive version and a negative version. My positive version looks like this: a squared plus 2ab plus b squared, and that breaks up into a plus b times a plus b, or a plus b squared. And then we have a squared minus 2ab plus b squared, and that is the negative version. That's a minus b times a minus b, which leaves me with a minus b squared. So number 1, I am first going to look at my first term and my last term and do the A and C chart like we've done previously with my trinomials. I have 81 and 18. We know that 81 is a perfect square that breaks down to 9 times 9, and 9 plus 9 will give me 18. So we have x squared plus 9x plus 9x plus 81. We can group these and factor. And that leaves me with x plus 9 times x plus 9, or x plus 9 squared. This one is the positive version because all of my terms are positive. Moving on to number 2. You'll notice that this is not the same. We have one negative and one positive. So this is going to be the negative version of a perfect square trinomial. So instead of doing it the long way like number 1, for number 2, we're going to check to verify that my A term and my C term are both perfect squares. So p squared breaks down to p when I take the square root, and 100 breaks down to 10 when I take the square root. Now I'm going to verify that the square root of my last term and my first term added together is going to give me my middle term. So I have p and 10. If I add 10p together twice, that will give me 20p. So we know that this is a perfect square trinomial. Now I can write my perfect square trinomial with p minus 10, and that gives me p minus 10 squared. I chose minus because my second term is a negative. Number 3, I'm going to verify the same thing. We have m squared and 6 squared. If I take 6m and add it together twice, that gives me 12m. The only issue is that I need it to be negative. So instead of 2 positive 6's, I'm going to have 2 negative 6's. And that gives me negative 12m, which is what I need. So m minus 6 times m minus 6 gives me m minus 6 squared for my final answer. Number 4, we're going to break down my A term to x squared and my C term to 13 quantity squared. If I add 13x and 13x together, that gives me 26x, which is what I'm looking for. Since all of my terms are positive, that leaves me with x plus 13 times x plus 13. And my final answer is x plus 13 squared. Take a couple minutes to try 5 through 8 on your own. Pause the video here and come back for the answers. For number 5, it breaks down to x squared and 5 squared. We're going to verify that when we combine these two together, 5x plus 5x, it gives me 10x, which is what I'm looking for. All of my terms are positive, so I follow the pattern x plus 5 squared for my final answer. For number 6, it breaks down to x squared and 8 squared. Since all of my terms are not positive, we know that if this is a perfect square trinomial, it will add to be negative 16x. So both of my terms need to be negative. So negative 8x minus 8x gives me negative 16x, which is what I'm looking for. So that's x minus 8 squared for my final answer. Number 7, we're going to check this one. That gives me 2x squared and 3 squared. When I combine these two together, that gives me 6x. I add it to itself to get 12x, and that works. So it should be 2x plus 3 squared as my final answer. And number 8. Remember, perfect square trinomials have to follow the pattern ax squared plus 2ab plus b squared, or ax squared minus 2ab plus b squared. So I have a plus and a plus, or a plus and a minus. For number 8, I have 2 minuses in a row, which is not a candidate for to be a perfect square trinomial, because you cannot take the square root of a negative number. So I can't take the square root of negative 36 and give me 2 of the same number. So this one cannot be factored. That's all for today's note.